Okay. This is to cover section 3 and 6 of chapter 2. The bell work for today was this logic puzzle. We're not going to go over it, but you are more than welcome to work it out if you would like. Okay, so sections 3 and 6 basically cover postulates and diagrams. We're going to name these postulates. We've kind of been building up to them, but we're going to name them. We're going to write them down. We're going to say these postulates and theorems are postulates and theorems. These are the rules that we're going to work by. And then we're going to sketch and interpret diagrams. Remember that the definition of a postulate, that a postulate is a rule that is accepted without proof, and a theorem is something that can be proven. Okay. Right angle congruence theorems. All right angles are congruent. All right angles the measure of all right angles should be equal to 90 degrees. Right? So we say that right angles are angles are congruent when their measures are equal. Therefore, if all right angles, their measure is 90 degrees, then all right angles are congruent. If two angles are supplementary to the same angle, then they are congruent. Okay. Let's say we have angle 30 degrees, and then we have another angle that is 150 degrees, and a third angle 30 degrees. Okay. These two angles that I have circled are supplementary. They form, when we add them together, they're 180 degrees. Well, if we then add our 150 degree angle to this 30 degree angle, they will also be supplementary, or add up to equal 180 degrees. So that means that this angle, let's pick a different color, black, that this 30 degree angle and this 30 degree angle are congruent. Okay? If two angles are complementary to the same angle, then they are congruent. Same reasoning as the last one. This time they're going to be complementary, or they're going to add up to be 90 degrees, versus the last one was supplementary, which is 180. A linear pair postulate. Okay, we have two angles, and they form a linear pair. Therefore, they are supplementary. Or the sum of their measures is 180 degrees. Vertical angles. Okay. This is going to follow the congruent supplements theorem. Okay. We have angle 1 and angle 2. Angle 1 and angle 2 are supplementary with 3 and 4. So that means 3 and 4 are congruent to each other, and then 1 and 2 are congruent to each other. So vertical angles are congruent. Okay. Sketch a diagram that shows our line intersecting a segment at a point. Okay, so we have a line, T, W, and it intersects a segment, P, Q, at point W, so that TW is congruent to WV. So we have our line and our segment, and they intersect at a point, and then the little ticks, these little blue ticks, show that T to W is congruent W to V, and that should be a V. Okay, on to the next one. We have a line that is UW and a point V that is collinear with U and W. We have a ray VX so that VX is perpendicular to our line. Done. Now this VX could have come off towards the bottom, could have been more left or more right, as long as your picture has that it is on the same line with U and V, and there's a right angle, we're good to go. Next we have our segment A and C that is bisected by B and D, but the two are not congruent themselves or equal themselves. So they bisect each other, so the parts of each other are congruent, but they're not going to be congruent to the other. Okay? Okay. Can we tell yes or no from the picture? A, B, and F. A, B, F. Are they on the same line? Yes. Next would be E, B, and D. We would say no because there is not a line drawn from E through B to D. On your paper it may be hard to see, but on this picture it's a little easier. There is a right angle coming off of AB and going down to plane S. So our line would, yes, be perpendicular to our plane. But if we look at line CD, we do not see that right angle box, so it cannot be perpendicular. Or we won't assume it's perpendicular. Next, line AF. Okay, let's look. Line AF, which is this line, intersects line BC, which is this line, at point B. Well, I would say yes, because that's where they both meet. Next, we just want to know yes or no, can we assume this? A, B, C are collinear. So A, B, C. Collinear means on the same line. Is there one line running through all three? No, so no, we cannot assume it. Is E the midpoint of BD? We are not told that BE and then ED are congruent. So we would have to say no. AC perpendicular to BD. Perpendicular lines have to have a right angle, so we could say yes. Is AD equal to CD? Well, we have these tick marks that tell us yes. So, that's it for this part. There are 2 practice worksheets on the back side of your notes for extra practice, and this is the homework. Hope you have a great day.